Hey student, this is your teacher, Mr. Smith. Yesterday's few of guys you said that, Mr. Smith, could you please have a class of conservation of mass theory, right? So few of the students they tend to get confused about the conservation of mass theory, how it has to be applied. What is the exact meaning of conservation of mass theory? Today we're gonna go for that topic. Okay, here about conservation of mass theory. Okay. Cons- Mass theory. Right. First and foremost, I would say this mass theory is being proposed by a great scientist who is none other than Antoine Lavoisier. Okay. So he is a great scientist. Even he's said to be known as father of modern chemistry, I would say. Father of modern chemistry. Okay, remember who is father chemistry then? Father chemistry is Robert Boyle. So he is known as father of modern chemistry. Okay, so in fact let's get begin with today's most important topic is called conservation of mass theory. What is the meaning of conservation of mass theory? How we could define it? So in fact I would define that conservation of mass theory describe about the mass neither be created nor be destroyed, but can be transferred one compound to another compounds. Okay, as you could know about the conservation of energy. Energy neither be created nor be destroyed, but it can be transferred one energy form to another form, like heat to light, light to electricity. This is just a form of energy. Similarly here, the mass theory also describes mass. We cannot create it, we cannot destroy even, but it can be convert one compound to another compound. In short, I would say that in the chemical reaction, there is no changes of mass. When a compound undergoes chemical reactions, there is no loss, no gain of mass. Mass will be remain same. Okay, before chemical reaction and after chemical reaction. Let's have a example. Let's suppose, let me take over here calcium carbonate, which is said to be in other word limestone. When limestone is being treated on heat, when limestone is being given heat and temperatures, it's gonna decompose into a couple of compound is called quicklime and carbon dioxide in other hand. Okay, so here in fact this is known as calcium carbonate, or you can say limestone. This is quicklime, right? Or in simply you can say lime, and this is carbon dioxide. Carbon dioxide. Okay, so here limestone is being heated and produced two new compounds. Limestone formula calcium carbonate. After heating you could find it calcium oxide and carbon dioxide gas. Okay, so before chemical reaction how many atoms are there, and after chemical reaction we must get the same number of atoms. I would like to say that it is called reactant and this is called product. So here reactant must be equal to product. The mass of reactant must be equal to the mass of product. So let's have a look here and let us find the mass of calcium carbonate and let's check it they are equals or unequal. If it is they are equal, then it will satisfy law of mass theory. If it is unequal, then it won't satisfy law of conservation of mass theory. Okay, so let me count it. Calcium is actually having mass, atomic number of calcium is 20, its mass number is 40. Carbon atomic number is 6, its mass number is 12. Oxygen atomic number is 8, its mass number is 16. So 16 3 times, because 3 oxygens are there. 16 3 times is 48. So if it will add, it will get around 100. So reactant side you got it 100. The mass of calcium carbonate 100 gram or 100 AMU you can say. So let's find out after the chemical reaction two different new compound formed, though we have to get the same atom or same mass. Exactly. If at all you get it, then this is satisfy law of conservation of mass theory. If not, you have to go for some other method to satisfy law of conservation of mass theory. That's going to be balancing chemical equations. Okay. So here let us count it. For calcium is 40, oxygen, here's 1 oxygen 16, plus 1 carbon is 12, plus 2 oxygen is 16, 2 times is 32. So 46 and 12 plus 32 is equal to 100. So we got it, reactant is 100 atoms, and the product also you got it, the mass of reactant is equal to mass of product. If what all you found to be noticed, the mass of reactant is equal to the mass of product, then that equation is satisfy law of conservation of mass theory. Because law of conservation of mass theory says that mass cannot be created nor be destroyed, or in other word I would say in short that the mass of reactant will be equal to the mass of product. So here mass of reactant is 100 and mass of product also 100. So this is satisfied by law of conservation of mass. There is no loss, there is no gain. Do you find any loss? 100 was there, after chemical reaction also you got it 100 only. So there is no loss or there is no extra gain also. So in this condition we could say that law of conservation of mass theory. Okay, so mass of calcium carbonate 100 grams. Let me write here grams. So mass of calcium oxide and plus carbon dioxide, both. Of course it is a new compound after the chemical reaction, but you got it the same gram only, same number only you got it, right? 100 grams only. Though these are the different compound. So mass only can change forms. Okay, one compound to another compound. This is one compound to another compound. Okay, it was before calcium carbonate, change into calcium oxide and carbon dioxide. So mass neither be created nor be destroyed. So I hope it is clear for you. Once again let me repeat it. Law of mass theory or conservation of mass theory described the mass of reactant must be equal to the mass of product. If at all the mass of reactant is not equal to mass of product, that kind of equation, that kind of chemical equation won't satisfy law of conservation of mass theory. So in order to satisfy law of conservation of mass theory, we're gonna go for balancing chemical equations. Now let me write one examples over here. If at all you write here, let's say hydrogen gas, when it is being added with oxygen, we tend to get it water. Okay, so now you tell me from this equation it is satisfy law of conservation of mass theory or not. Can you find it? How we will understand it? This equation satisfy law of conservation of mass theory or not? How we will check it? We have to calculate the mass of reactant and mass of product. If at all the mass of reactant is equal to the mass of product, then it is satisfied. If it is unequal, then it doesn't satisfy. Let's see here. Hydrogen mass, because one hydrogen is 1, so 2 here 2. 2 plus oxygen, 2 atoms are there, so 1 oxygen 8, mass number is 16. 16 2 times is 32. Right. So reactant mass we will get it 34. Now find the product side. Hydrogen is 2. 2 times. Right. So 2 plus oxygen is 16. So total is 18. Now see, reactant side we have the mass of hydrogen and oxygen, if total you add together 34, and the product side only we are getting 18. That means the reactant is not equal to product here. So this won't satisfy law of conservation of mass theory. To satisfy law of conservation of mass theory, we gonna go for balancing chemical equation. If at all you balance it, then we will get it. I mean, it will satisfy law of conservation of mass theory. Is that clear? So this is all about the mass theory. If at all you have any queries regarding conservation of mass theory, which has been given by Antoine Lavoisier, okay, so just let me know, just comment below, and have a beautiful day. Thank you so much.